Right, so I had a quick look, and we were 35 minutes in from before or something like that, so it's not too bad, but there's lots to come, so I don't know, get comfortable. As we, just a quick look back, we created the major structure for the violin body. We've got the bass bar in. Let me make the top translucent so we can see inside. I forgot to mention one other component, which is the sound post here. And the sound post connects the top plate, the belly, to the back. This is very important for the mode of vibration, as is this bass bar, which stiffens up this one bass side of the belly. Probably go into the physics of it later. It's pretty interesting, but suffice to say, this was created in context so that it sits flush on top and sits flush on the bottom as well. You can see it there. And this is also something that the violin maker would spend quite a lot of time whittling away and tapering to fit exactly. You don't want these things to fall over. They're not glued in. They're just held there by the tension of the strings, which compresses the belly somewhat, and it stays up until it falls over and you have to get someone to help put it back up again. Anyway, what we're going to do now is go back to some more modeling, and you'll see a whole series of prefixes of ICPS, and that stands for an in-context part studio. So I've used that for the bridge, the sound post, the tailpiece. Actually, no, the tailpiece is not in context, but there are a few other things. So let's have a look at some of them. Now, the reason that the bridge is done in context, it's a final adjustment to the shape of the feet, because this has to fit exactly onto the this has to fit exactly onto the belly. So the context for it, and if I bring back the context, is just the belly plate like this. And I did a replace face feature, which took the original face of the foot of the bridge, which is extended quite a bit further down, and after I'd positioned the bridge, I just did a replace face with using the face of the belly as the reference, and now it has perfectly cut that bridge. Again, this is laborious work for the luthier to do this. It needs to be very accurate and fit perfectly, but it's perfectly a good use of in-context part studio and edit in context in that case. The sound post, I think I mentioned that before. This was done in context with two plates, in fact. So I'm using the replace face trick again, I think. Oh no, I didn't. I just started the sketch, and the top plane there, front plane, and extruded up to that face there, and up to in the other direction that face there. And that ensured that this is, again, perfect. Way more perfect than you would ever kind of do by hand. What else is interesting? The tailpiece. This is a nicely styled. This is not done in context. It's pretty simple, but you need to get the shapes right. Simple piece of parametric modeling there. I don't think I did anything too fancy to talk about. Not really. Okay, so let's move on. The end pin. This is a tapered pin. Nothing too fancy there on that. All of the really interesting stuff is going to happen here in the scroll. This is challenging because it is hand carving, right, to get this. And I've seen a couple of models kicking around, and there's some good ones and there's some not so good ones. And I took a whole new approach myself to do this. I'll try and talk you through it a little bit. Let me roll back to here and bring up a reference image. So this reference image is from a famous old violin. It wasn't mine, but it just happened to be a convenient one that I could find that had dimensions on it, which was great, you know, and it shows you the spirals and the decreasing, whatever these dimensions were. And there's all sorts of other great references on this picture, which is the distance between the pegs. The tuning pegs are in here. From this front view, you can see the shapes of the spirals that are being cut as well. And this is a cross section that will be used a bit later on. So this was a great reference, and we'll keep it there. But what I did is I created a sketch called my scroll profile. This is going to be my basic thing on the center plane that I'm going to use for driving everything else. Now, these 13 features took a lot longer than 13 features might you might believe. So I'll try to. This is how I ended up. I did many different ways approaching this. Came up with this one here. So I extruded a cylinder, and then I created a helical curve around it, which is the exact number of turns. I think it's 2.5 that I needed. No, not exactly. Let's see that helix. It's 3 turns. Yeah, sorry. And it's a pretty simple one. We've done a lot of work on helix lately, and you know, there's some nice new options, but I think this was using pretty much the standard options from before. I created a new sketch, which is a very important one. Now this sketch, if I highlight it, is going to, you know, these are increasing sizes from the top, longer, and this is going to be the kind of the lengths. It's going to form the extrusion when I start. Well, actually, it's going to be a loft. Spoiler alert, it's going to be a loft. Let's turn off the image. Getting confusing. All right, one more sketch in here, which is from the other direction. This is probably the controversial one here that, you know, I'm not happy necessarily with the aesthetics of that dishingness on it. But anyway, I created a loft, and that loft looks a lot like this. So yeah, you can see I probably overdid the curve on this one here, but it ended up being pretty good like that. And then what I did is I extruded a helping surface in this direction. So I used that reference at the beginning. Remember, this is the scroll profile. I used those scrolly looking edges to extrude up here, and then I'm going to do some fancy enclosing. Let's turn off those surfaces, which left me with this solid part, which is the bulk of, in fact, looking pretty good. And then I booleaned it to that cylindrical part, and you can start to see where I was heading with this. Then the trick was to transform this off the main center plane, extrude it back to the center plane, and then mirror it across the center plane. And now we're really cooking with gas, because this is only 13 features. I'm pretty proud of the fact that this worked out so well. And then it was a matter of moving further down the neck into what they call the peg box. That took a similar amount of work. Let's just move to here. That was another loft, which we then continued down the neck to create the neck here. And there's a bit of filleting. I think I did a face blend. Face blend was a little bit easier to control for this. You know, a lot of these are really hand carved, and it's very free form. So a face blend gave me a little bit more control over that. And I colored these differently because they are stained differently in real life. So that's why I did different face colors. Now the fingerboard is the bit that sticks up the top. Where is that? That's up here. So very closely related topology. It belongs in the same part studio. And then there's a scoop, like a scalloping that goes up out underneath here. That's a loft that goes from this curve to this line segment, that line segment to that. That's a loft, and cut it out there. So that was this loft and a split. I created a surface loft and then split this solid part with the surface. Now we need to make some space for the pegs to go, and that's going to hollow out this box here. Nothing too fancy in there, and then I cut the peg holes. So the peg holes again came from that reference image that we looked at the beginning. I cut the holes, and then I actually, in a different part studio, have a peg taper part, and because it derived into where the part studio's origin was, it's up there, so I needed to transform it and put it where the peg is going to be. And I did that 3 more times to create the 4 pegs. This is where the pegs, and you see how they're tapered. There's a very specific taper on this. I think it's a 1 in 30 taper. I actually have another part studio that defines that. Then I used a Boolean to extract that and leave the holes. So leaving me the tapered holes in the correct location. The last bit of aesthetic work was with the scoops. There are these twin kind of channels that go along. Now this is again a pretty tough one to mimic, a freeform type of carving operation, but it ended up being pretty good, I think. Let's compare back to the image. Oh, it's kind of convincing. I like it. And then that is pretty much the end of the end of this side of it. Probably more I can do. I'd probably change the curvature of this a little bit, make it a little bit flatter there. But other than that, and maybe knock some hard edges off, maybe put some chamfer or fillet along these very sharp edges. Other than that, it's pretty darn close. So if I go back to the full assembly, then we can see the scroll in place. In fact, there's a little bit more trimming that I have to do around this plate here, the back plate and the neck. I haven't finished this. That is pretty much it. The only other one thing I wanted to say was about the strings and the tuner. The strings look pretty cool. The strings were done as one of these other in-context part studios. So let's have a quick look at that. So you can see the context. That's the stuff that's in the ghostly colors. I've chosen the tailpiece here. The front and back surface, or the bridge itself, is in context. The fingerboard and the nut up here is and the fine tuner. They're all part of the context. There's a lot of controls now we have on context if you want to hide and show and change what is in it. So you can see here that we have a new way to access that through the assembly context menu here. Of course, if it's out of date, it would have told me, and then I could have had a chance to update the context. But I don't need to. It's not out of date. So what I did is I created a whole bunch of mate connectors at very strategic places along this path of the string, right where the string would start, where it jumps over this the bridge here, and the end saddle. top of the bridge, there's two mate connectors, and there's a mate connector and two mate connectors up the top there. So once I created all these mate connectors, I then used a freeform spline. This is actually a custom feature, and I just followed between all the mate connectors and created that spline. Now I could have done this in different ways. I didn't have to use a freeform spline feature, but I happened to be playing with them at the time and thought it would be a good test. So once I had the spline in place, I created a sketch, which is the cross section of the string. Let's have a look at that. It's down here. Let's show the dimensions of that. It's 0.5 millimeter. So the E string, the top string, the treble string, is 0.5 millimeter diameter, and the sweep then takes care of the creation of the string itself. I did that for all the G, D, A, and E strings, and then inserted that back into the assembly as so. And what that means is that I can change the, if I change this, I think I can do it here. Now, how do I do that? I'm trying to remember that. There's a way, the way I set this up before, and actually I probably configured it or something like that. That I can change the height of this adjuster, which then changes the length of the string, which means that I need to update the context and have the strings update. But I think at this point we have covered the major things. The only other stuff that I probably would mention, there are some other checks on angles and distances that you can do. There's some specific one here, which is the intersection point. You know, if you take the intersection between the line that runs along the fingerboard and the perpendicular bisector of that with the bridge, then you measure that down to the belly. That's 23 millimeters. There's some, you know, this is a really nice use of in context part studios as well, because I'm creating this kind of complicated construction geometry to do some very detailed measurements, and they will remain associative to the assembly because they're done in context of the assembly. So I did a few things like that. From here on, you know, I just was always doing renderings. This is an interesting rendering here. You can see these edges are actually rounded, and that is the Render Studio doing that. There's a material option to automatically apply radiuses to sharp edges. I've used that in a couple of places. The gloss or the clear coat on this is trying to mimic the varnish. You can see some grain underneath it. It looks fairly realistic like this. Some nice beauty shots of the scroll. Pretty proud of how that worked out. And you know, here's some, you know, finally the trimmed versions of that. More shots of the scroll. Anyway, I'll leave it at this now. I think we've taken pretty much a grand tour through the project I've been working on. If I think of things that might warrant, you know, deeper dives, I'll think about throwing some other videos together on that. But I think that this should give you an idea of, I don't know, the huge breadth and depth of features that Onshape now has, and the things that I've been able to call upon to get this project done. Always thinking about what's coming next, but I'm still liking this one.